2, 3, 4. Of course, we can give numbers and purpose and meaning to these numbers here, but we'll just look at what they look like first. So this right here, this A, this is the name of the matrix. This is what you're using for your Kramer's rule, Christian. And you're using matrices. How many rows does this matrix have? 2. How many columns? 2. Okay. So A is a 2 by 2 matrix. So A is a 2 by 2 matrix. Those are what we call the dimensions. And the dimensions go rows by column. So you list the number of rows first, and then you list the number of columns. Now, when I put this matrix together, did I use any commas or any sort of separation between the numbers? No. So it's just the numbers that are in there. So matrix A has 4 elements. So what are the elements of a matrix, basically? If there's 4 of them. How many numbers are in there? So there's 4 of them. So there's 4 elements. Periodic table of elements. Just whatever is up there. Let's say this is B. So B is that right there. How many rows do we have? 1. How many columns? 3. 3. So how many elements do we have? 3 elements. 1, 2, 3. What are the dimensions? 1 by 3. Let's say B is a 1 by 3 matrix. So one thing you can use these for, is just the presentation of information. So here's an example. They've given us a table, and they just say to organize the data in a matrix. So the relationship between a table and a matrix is not very different. You're just not going to be making a table. Okay. So when you look at this, though, this age, that's a range of numbers. You're not going to be putting that into a matrix. Okay. You can only put specific values in there. So these numbers right here are the only numbers that you can put in there. Now you can have labels on the outside just like a table. So if I just look at the numbers here, how many rows do I have? 4. How many columns? 2. So what size matrix do I need? 4 by 2. And we can also make labels along the outside. So if I scroll up here at this example that they did in the book, you see how they wrote a matrix. So here's your bracket. They have the data on the inside. They have their labels on the outside. Okay. So you see how that could be, if you just draw a table around everything, it looked like a table. So if you want to draw a matrix out of this, we're basically going to put brackets around this, and the rest of the labels can stay the same, the numbers would stay the same. Okay, so let's do that. Let's draw out organizing the data into a matrix. This is example 1. I usually start with the matrix. And I'll put the labels on the outside. One thing that would be different is you don't have to use titles with the matrix, you just need the labels pretty much. So those numbers are inside the matrix, imprisoned by their own technology. So this lesson will be about using matrices, and it's going to be about operations, basic operations with matrices, which are addition and subtraction basically, and then what we call scalar multiplication. So the next question here, it says add the elements, so we know what elements are, those are just the parts of the matrix, in the columns and interpret the results. So the big thing there is interpreting the results. So if we are adding the elements in the columns, am I adding down or am I adding across? Am I adding the 7.1 to the 6.8, 3.2, and 1.1, or am I adding the 7.1 to the 6.6? Down. So add the elements in the columns. Columns go up and down. So we need to add that up and then interpret what those results mean. I'm going to present my answer in a matrix. My answer would be a 1 by 2 matrix now. So, good question. If we're adding the columns, what do we do with these outside labels that's over here? This will help us interpret the results. So, all ages, and this is the interpretation, if you add the columns, the number that you get represents the total, right? So now we look at the label. We're dealing with the Latino population in the U.S. in millions. So you get 18.2 and 16.1. So the interpretation would be these represent the total male and female Latino population in the U.S. in millions. We have to include that in millions because it's not 18.2 total people there, it's 18.2 million. That'd be 18,200,000. So when they want you to interpret, it has to be some sort of statement, some sort of explanation of what does your answer, your number answers represent. Communicating what the math is telling you. Okay. Go on and look at part C. I don't have this down. Part C is saying add the elements in the rows and interpret the results. So add the elements in the rows. So go across. You're going to make a new matrix. These two together, these two together, these two together, these two together, rows first. So 4 by 1. So 4 by 1 matrix. So now you're going to lose your male and female headings, basically. You're making it into a column matrix. We call it column matrix. We just made a row matrix when it has one row. You agree with my numbers?
Top one.
2.7. 2.6. 1.1 plus 1.4. So now interpreting these results, each number in each column, instead of representing the total male and female Latino populations, it's representing the total population in each age range. Okay, so you'd write something like these numbers represent in millions the total Latino population in each age range in the U.S. Population in millions in each age range. Try to say that 10 times fast. Age range, age range, age range. Try saying it 5 times fast. You're all doing it under your breath. Okay. So the main thing there is the math isn't hard, it's being able to interpret what the math is saying. Okay? That's the main important thing with those problems. Do you think finding the average would help us with anything?
Of age. Maybe.
You find the average for each group, or for each age group.
The average, like going across here. So the average between male and female. Good. I'm not sure if that's really helpful.